Hi friends, we are discussing polarization, and under that in the last session we discussed about Nicol prism, its structure and construction. Now in this session we will try to understand the working of a Nicol prism, how it works. So let us consider a Nicol prism. Called as DDFH. Extend that. Called as H double dash. This is double dash or single dash, whatever it is. It is B dash. So this is the optical axis. Two plates are joined together with, as I told you earlier, Canada balsam. Now this is the optical axis. Now this is 90. Up to this point. This is 40 degrees. This is 68 degrees. Again, this is 90. Now on this, let us assume a ray is incidenting like this. All this as S, M. This is S dash M. This is S double dash M. So the ray SM of a light is made to incident on the front face dB dash of the Nicol prism. The incident beam now here is split into two beams, namely ordinary and extraordinary. How it splits? Now this ray is split. So therefore you will have extraordinary ray coming like this. This is ordinary ray coming like this. This is O ray. This is E ray, extraordinary ray. Now here you have used balsam layer or CB layer we call this. This CB layer or Canada balsam layer is a rarer medium. Rarer medium for the O ray. Because this Canada balsam is a rarer medium for the ordinary ray, therefore the ordinary ray is traveling from a denser to a rarer. What it means? It means O ray is traveling from a denser medium. What is denser here? Calcite only. No? From a denser medium to a rarer medium. Here the rarer medium is the Canada balsam layer we have used. So when it is entering from a denser medium to rarer medium, what happens naturally? It implies that this ray undergoes total internal reflection. It is totally internally reflected. Because if angle I, that is the angle of incidence. Angle of incidence made by whom? Made by O ray. At what? At CB layer is greater than the critical angle. So whenever angle of incidence is greater than the critical angle, it undergoes total internal reflection. That principle is already known to us. So therefore, the critical angle for ordinary ray, especially for calcite crystal, calcite to Canada balsam, it is given by what? Critical angle theta c is equal to sine of refractive index of that is 1.55 divided by 1.658. Now this, if you simplify, will come to around 69 degrees or 69.2 degrees. 69.2 degrees. Now, in order to make the angle of incidence made by ordinary ray at the calcite and CB interface more than the critical angle, then automatically here you have to get it out. Why we are taking these two? So here we are getting the critical angle is as 6.92 degrees. So when do you get this? Only when angle I is greater than angle C, more than the critical angle. So to get the angle of incidence for this ordinary ray at this interface, to be more than the critical angle, that is, for angle I to be greater than angle C. This is in the case of ordinary ray. What should happen? Angle of upper and bottom surfaces of the crystal is grounded from, see here we kept it as 68, not 71 as said earlier. Why we have done that? To get angle of incidence to be greater than critical angle, to have the total internal reflection, the upper and bottom surfaces of the crystal is grounded from 71 degrees to 68 degrees. And we know that length of the crystal is taken as 3 times breadth. In the last session I told you, in the structure of calcite crystal itself, called prism, length will be always 3 times the breadth. This is for ordinary ray. So let us look at extraordinary ray. Now for E ray you are talking about. When we talk about extraordinary ray is travelling from where? Extraordinary ray is from Canada balsa. That means this is a denser layer. So since CB is a denser medium, so what is happening in extraordinary ray? It travels from calcite, that is rarer, to CB, that is denser, quite opposite of that. Now in the case of extraordinary ray, it is traveling from rarer medium to denser medium. So therefore, naturally it travels in a straight line. If you observe the picture, extraordinary ray is not undergoing any deviation. Only this is undergoing deviation. This is because here angle of incidence is more than the critical angle. Now here it is undergoing total internal reflection. Therefore you observe a deviation. Whereas in this case, it is traveling from a rarer to denser, then you don't find any deviation. So it travels from in a straight line and emerges out from the Nicol prism. So the emergent beam is a plane polarized light. So it travels in a straight line and emerges out from Nicol prism. That means this emergent beam of extraordinary ray is a plane polarized light. Understood? So let us understand in the form of a geometrical approach, right? Now we are using the word Nicol prism. Why we use Nicol prism? The purpose of using Nicol prism is to produce and analyze. Produce and analyze plane polarized light. This is the purpose of a Nicol prism. Nicol prism purpose is to produce and then also analyze plane polarized light. This is the purpose of Nicol prism. So let us understand geometrically produce and then analyze plane polarized light now. Consider a polarizer, one prism. Okay, a Nicol prism. This is the Canada balsam layer to join this. This is polarizer P. Now when light is incidenting, now you will have unpolarized light coming. This is unpolarized light. Now here you are making it to pass through an analyzer. So analyzer also looks the same. This is analyzer. Now this extraordinary ray. Here it is divided. So unidirectional vibrations can be seen here. Like this. This is extraordinary ray we are talking. And here ordinary ray is happening. That means it is splitting into ordinary and extraordinary rays. So ordinary ray is cut off when it is passing from calcite to Canada pulse. Whereas the extraordinary ray is passed through it. If it is passed through another Nicol prism, let us say analyzer, which is kept parallel to the first one, the extraordinary ray is passed through. Carefully observe. Here, I am repeating, ordinary light is made to fall on a polarizer. Now at this point, the ordinary ray is cut off at the junction of calcite to Canada balsam layer. Medium difference is there, therefore it has undergone TIR, therefore it is diverted. It is cut off here. The rest of the ray, which is only extraordinary remaining, that is passing through another Nicol prism, which we call it as analyzer. It is passing through that, which is kept parallel to this. Now if you want to analyze this, an interesting feature will be understood. How to analyze this? This is production. Now let us see the same thing. This is the polarizer. This is the Canada balsam layer. CB we are talking about, separating the rarer and denser. An unpolarized light is falling. So therefore, at this point, it gets cut off as an ordinary ray. After it is cut off, the rest is traveling, extraordinary ray is traveling. Till this you don't find any difference between this and this. Now here, this polarizer and analyzer concept again applying. This polarizer, this analyzer, let me say I will rotate it. That means the second Nicol prism, after passing to the first Nicol prism, the ray is made to incident on a second Nicol prism, which is rotated by making the incident beam as axis. So therefore the emergent beam from the second Nicol prism, it gets extinguished twice and it will have maximum intensity twice and for one complete rotation. That means here what will happen is, once it is made to fall on this, it will pass through certain distance. Somewhere here calcium balsam layer will come. From there, it turns like this. This is the analyzer. See the difference. This I have already explained. I am again telling you. The purpose of Nicol prism is to produce and analyze plane polarized light. Here what we are doing, we are considering an unpolarized light passing through the Nicol prism. It is split into two rays, ordinary and extraordinary ray. The ordinary ray is cut off when it is passing from calcite to Canada balsam. The extraordinary ray is passed through. If it is passing through another Nicol prism which is called analyzer, it is kept parallel to the first one. The extraordinary ray is passed through it. This is the first one. Now in the second case, very interesting thing is happening. In the second case, up to this point common, if you make the second Nicol prism as a rotating one, that means if the second Nicol prism is rotated by taking the incident beam as an axis, then the emergent beam from the second Nicol prism is extinguished two times and has a maximum intensity. Here already it is done, again it is undergoing, that's why it is twice, and it has maximum intensity two times with one complete rotation. The first Nicol prism is known as polarizer and the second Nicol prism is known as analyzer. Thus a Nicol prism can be used as a polarizer and analyzer also. Understood? This is how the plane polarization of light can be understood with the help of a Nicol prism, using it as a polarizer and analyzer. But one thing we have to remember, there are certain limitations even for a Nicol prism also. What are they? Let us understand. If you look at the limitations of Nicol prism, so what are you doing with Nicol prism? You are making it to act as a polarizer, let us say. It can act as a polarizer only for those light rays that have slightly convergent and slightly divergent beams. That means more convergent and more divergent beams cannot be used for, polarizer cannot act for such beams. And that means, what does it mean? If the incident beam is more divergent or more convergent, Nicol prism